Okay, so here we want to look at sex-linked, and specifically we're going to focus on what we call X-linked. Because X-linked can affect males and females, Y-linked only affects males, so we tend to not really spend a lot of time talking about this. So these are specifically located on what we call the sex chromosomes. If you remember, we talked about the fact that humans have 23 pairs of chromosomes total. That of those 23, 22 pairs are what we call autosomes. And the other pair are going to be our sex chromosomes. And it works out pretty easily. If you have two X's, it's going to be a female. And if you have an XY, it's going to be a male. And what we have found is that there are genes on these chromosomes just like there are genes on any of the other chromosomes. But because of the XX versus the XY, we see certain traits show up in males that don't show up as often in females and things like that. So how we work a sex-linked cross is the characteristic that we're dealing with is going to be what I call floating. It's a superscript on the X chromosome. So, for example, on the key that we have for this notes page, we have X with a capital H stands for a normal blood clotting factor, and X with a lowercase superscript h gives us a disease called hemophilia, where the blood does not clot properly. Sometimes it's also referred to as the royal disease because it originated with Queen Elizabeth, excuse me. I'm telling you the wrong queen. And there is no trace of it prior to that time. So, we do this problem just like we do any other. So we have our Punnett square, just like we normally do. And this is, right now, this is just our normal 2 by 2, but I could include this in a dihybrid. It still works the same thing. The father, it said, was X, capital H, Y. Now notice the Y does not have a superscript on it because the Y doesn't carry this trait. It's only found on the X chromosome. So dad only has one X chromosome, hence he only has one. Okay, mother, we have X, capital H, X, little h. Females have two X's, so each X is always going to have this letter for the sex-linked, X-linked traits. We do the cross just like we normally would. So here we have a female that is normal clotting. Here we have a male normal clotting. Here we have a female that is normal clotting, but we can say that they are a carrier or heterozygous for hemophilia. And then we have a male who is a hemophiliac. He has hemophilia. Why? Because he only has one H, and it's the little, because there's only one X chromosome. So when I do my genotype, I would say there's one female normal, 1, there's 2 females that are normal, right? 2 females, and 1 not female, male. Ah, I'm writing the wrong thing, aren't I? So 1 male normal and 1 male with hemophilia. What would that be in percentages? Well, let's see. It'd be 50% females normal, 25% male normal, and 25% male with hemophilia. So once again, this one's probably the most different out of all the ones we've done because we're using that X and Y, and then our little character letters are superscripts on the X found with the parents. Okay, there's your sex-linked video.